All right, now we need to talk specifically about the renal capsule. So the renal capsule is the glomerulus plus, let me do this a different color, plus Bowman's capsule. So if we draw all right, so if we draw our capsule, so this is Bowman's capsule, all right, and if you can see this, it's got basically two layers, so a layer here and a layer here. This layer out here is called the parietal layer, and that should make sense. It's kind of like the serous membrane. Okay, so the outer part of that membrane is the parietal one. It's the one that lines the cavity. So this is sort of the outer layer there, and it is made up of simple squamous epithelium. Okay, the inner layer over here is called the visceral layer. And the visceral layer is made up of these cells called podocytes. And podocytes are these little octopus-like looking cells that have sort of like a cell body, and then they have like these little interdigitated little arms off of them, off of the cell body. It's a terrible picture, but you get the gist. It's like the little arms have little fingers on them. They're called pedicels or something like that. And the arms themselves interdigitate. So they interdigitate with other podocytes. Okay, I know that's a terrible picture, but this arm is in between this one and this one. Okay, it like put your fingers together, interlace your fingers, and that's how podocytes wrap around the visceral layer there. And it allows for basically filtration. It acts on, like, the capillaries here are fenestrated, so they're leaky, and this allows the filtration of the stuff to come through. Anyway, so podocytes are what are going to line the visceral layer of Bowman's capsule. Okay, so if we we need to look at the glomerulus. Remember the glomerulus? So that was Bowman's capsule. This is the glomerulus, which is the other part of the renal capsule, or renal corpuscle, excuse me, is a better, renal corpuscle is the glomerulus plus. Okay, I mean, the whole thing is a capsule but it's called this part of it is the renal corpuscle. Okay. So we know that this is just a knot of capillaries, right? Okay. And remember, this is the glomerulus. Okay. And the capillaries in here are fenestrated. Okay. All right. And we know that there's a way in and a way out, right? So the way in is through the afferent arteriole. And the afferent arteriole comes out and it's kind of big, relatively speaking. Okay. Out here, coming out, is the efferent arteriole. And the efferent arteriole is smaller. It's narrower. Okay. It's definitely smaller than the afferent arteriole. And that is kind of important. And it will be important in the physiology. I want to bring this out a little bit. There we go. Just want to bring it out further. Okay, so that's the efferent arteriole. Okay, so there are some cells that are associated with this area that are important that we need to point out. So if you remember when we were looking at the anatomy of the tube, here's Bowman's capsule, here's the proximal convoluted tubule here, PCT, and then it runs around to the loops of Henle, blah, blah, blah. And then it comes back up here as the distal convoluted tubule. And it actually comes around right through where the two arterioles are. So this is the distal convoluted tubule. All right, so in the distal convoluted tubule, right here are a set of cells. These cells are called I have enough room here. Macula densa cells. That's right here. Okay. These are the macula densa cells, and basically macula densa cells monitor the filtrate because there's filtrate traveling through here. Okay. In the capillaries, there are cells that are along the side here. And these cells are called juxtaglomerular cells. Okay, so these are juxtaglomerular cells. These are macula densa cells. The whole thing together, this whole area, is called the juxtaglomerular apparatus. Okay. All right, these juxtaglomerular cells also have another name. They're also called granular cells. So I'm going to put that too, because they can be called that as well. Same thing, just an AKA. Okay, so these juxtaglomerular cells and macula densa cells work together to monitor, the macula densa cells monitor the filtrate, and then the juxtaglomerular cells secrete a substance in response to the macula densa cells when they figure out that blood pressure's low and there's not enough sodium or whatever. So we're going to talk about that, but that whole area together is the juxtaglomerular apparatus, and it's going to be very important in physiology and blood pressure. Okay. All right. So that is the renal capsule, or the renal corpuscle. And I know this is a terrible picture of podocyte, but look it up. Again, the podocytes are here. The visceral layer of the Bowman's capsule is the podocytes, right next to the fenestrated capillaries of the glomerulus. So don't forget that either. All right, so now let's look at how fluid moves here.